All right, the second part of Chapter 10, we discussed comparing two means. The idea was very similar as it was for proportions. Now we just have two mu's, so mu1, mu2. We have two x bars and two sample sizes. The sampling distribution will be approximately normal if the population is normal or the sample size is greater than 30. The center of the x bars, this was previously, was mu. The standard deviation of x bar was sigma with square root n. But now what we're talking about is we're talking about the difference in the two mu's, so the difference in the two mu's. So we might need to find the differences in the x bars to estimate the differences in the means. So when we talk about the differences in the means here, we have a new sampling distribution. So the mean of that new sampling distribution is mu1 minus mu2. And the standard deviation of that new sampling distribution is the square root of sigma, is the square root of the variance of the first one divided by the sample size plus the variance of the second one divided by the sample size of the second. The shape will be approximately normal, again, as long as the population is normal or the sampling distribution is large enough. The mean is just the difference in the two means, and here's your standard deviation as long as that 10% condition is met. So they have just a question here telling you about the heights of boys and girls follow this normal curve here. So what's the, describe the shape. So both the populations are normal, so the sampling distribution is normal. The mean is just the difference in the two means, and the standard deviation, you add the two variances together and then take the square root. All right, then you can use that information to find probabilities. So here we could do, if I want to find the probability that the difference is less than 0, so I would just do, I would have done normal CDF, negative infinity to 0, comma the mean of 0.7, comma the standard deviation. They're going back and using the standardization and then using the table. And then they found this probability to be 33%. So there's a 33% chance of seeing that observed difference. So it's not unlikely to see that the males are greater than the females. Again, we have to deal with something called the standard error, and all we're doing is we're taking that standard deviation. So since we don't know sigma, we're just going to plug in the sample standard deviations. This is our test statistic, or we can use, and this test statistic follows a t-distribution. The t-distribution here in this case has a funky degrees of freedom. And there's a very accurate method with a crazy formula, or you can use a conservative approach using the smaller of those two equations there. Likewise with the confidence interval, when you find the critical value, you're either going to use the degrees of freedom from that crazy formula for technology, or take the smaller of those two. That's the conservative method. The random condition still needs to be met. The normal condition needs to be met. The independent condition needs to be met. For the normal condition, it is possible that sometimes you might have to make a graph of the values. And when you make the graph, you're just going to check the graph to see if it's looks roughly normal, like we talked about in the earlier chapter. So here's an example. They have two samples of 30 trees. They're looking at their diameter. This is the mean for the first one. This is the mean for the second one. There's the sample standard deviations. And they just want to know the difference in the mean for the longleaf pines in the northern and southern halves of the Wade Tract Preserve. So they just write here the true mean difference for the southern half, the true mean difference for the northern half, so they want to estimate the difference. I'm fine if you just write that out right there for that first step. Just at some point, make sure you define which one is which. All right, so the method here is a two-sample t-interval for the differences. Both were random samples. They gave us box plots here. They didn't tell us that the population was normal. The sample sizes are equal to 30, so it should be sufficient enough just to say that the sample sizes are equal to 30. So we're safe to use the t procedures. The independent condition here is met. the degrees of freedom, they're going to use the conservative method here and go with the sample size minus 1. They're going to look up the critical value in the table, and they're going to plug everything into the formula. So what I would have you do was, on your calculator, we would have gone to stat, tests. This is a 2-sample t interval. So I'm going to go down and find the t intervals. Oops, and of course it goes a little bit too far for me. Alright, so there's my 2-sample t interval. I'm going to select that one. So the mean for the first one was 34.5. Oops. The standard deviation for the first one was 14.26. The sample size is 30. The X bar for the next one is 23.7. The standard deviation for the next one was 17.5. The sample size is 30. The confidence level is, we're doing 95%, or no, we're doing 90%. Pooled, always say no for pooled, and we're going to hit calculate. And there's my interval. Now I'm going to get a slightly more accurate interval than they did, because if you look here, I'm using the degrees of freedom from the calculator. The degrees of freedom from the calculator are going to be different than using that conservative method. And then we would just write our summary statement like we've been writing before. Make sure you're saying which one is coming first when you did your calculations. Likewise, we move on to our hypotheses. So instead of having P1 and P2 in our hypotheses, now we have mu1 and mu2. But the idea is still the same. Most of the time we're going to be interested in the scenario where the difference is 0. So mu1 minus mu2 is equal to 0, or mu1 is equal to mu2. You can find the p-value the same way, so we can use technology, which I told you to do, or you can use the conservative method and use the smaller the degrees of freedom to find the p-value. Our conditions are the same as they were for the hypothesis test. Again, in that normal condition, you may need to look at a graph and see if it looks roughly normal or symmetric. So in this one right here, what I would have had you do is type in these values into a list and type these values into a list. You're doing a test that mu1 is greater than mu2. So the calcium group had a greater decrease than the placebo group. You're going to use the significance level of 0.05. And again, I don't know that it said that in the. If it doesn't say that in the problem, just pick something and use that. Go through the checks. They're going to do a check here by just graphing it. Again, you only need to pick one, but pick one and make a statement about it. The independent check is met. I would just have you use the data option and then take the p-value from that result. And make your conclusion the same way. We also talked about how we could use confidence intervals. Well, actually no. This is just another example of a confidence interval for the difference. So you can take a look at that. Again, I would have you just do it in the calculator. But you can do the confidence interval just like we did before to perform a two-sample test, or two-sided test, I mean. Just those rules that we talked about before with the T procedure still apply. So if your sample size is less than 30, check your graph. As long as there's no major skew or outliers, you should be good to go. It's even better if your sample sizes are exactly the same. Like I said, never check pooled when you're doing those tests. Don't use the two sample procedures for paired data. When they're paired data, you'd go back to your one sample procedures. And here's the summary.